Hello students, welcome to my YouTube channel Integrated Physics Studies IPS. ଏଥିରେ ମୁଁ ଅଲରେଡ଼ି ପ୍ଲସ୍ ଟୁ ସେକେଣ୍ଡ ଇୟର ସିଲାବସ୍ କମ୍ପ୍ଲିଟ୍ କରିସାରିଛି। ଏବେ ମୁଁ ପ୍ଲସ୍ ଥ୍ରୀ CBCS ଫିଜିକ୍ସ ଅନର୍ସ GE ଆଉ MSc ଫିଜିକ୍ସ ଅନଲାଇନ୍ କ୍ଲାसेसର ଭିଡ଼ିଓଜ୍ ଅପଲୋଡ଼ କରୁଛି। ଯଦି ଭଲ ଲାଗିଲା ତାହେଲେ ଭିଡ଼ିଓଜକୁ ଲାଇକ୍ କରିଦେବ ଆଉ ଚ୍ୟାନେଲକୁ ସବସ୍କ୍ରାଇବ୍ କରିଦେବ। ୟୁ କ୍ୟାନ୍ ସେୟାର ଇଟ୍ ୱିଥ୍ ୟୋର ଫ୍ରେଣ୍ଡସ୍ ଅଲସୋ, ଇଟ୍ସ କମ୍ପ୍ଲିଟଲି ଫ୍ରି ଅଫ୍ କଷ୍ଟ। लेटेस्ट वीडियो नोटिफिकेशन ପାଇଁ बेल आइकन को एठी ऑल रे सेट कर दबो। तापर वीडियोज रो क्लैरिटी बढ़ावा ପାଇଁ गो टू सेटिंग्स, क्वालिटी, एडवांस ऊपर क्लिक करी यू कैन इंक्रीज द रिजोल्यूशन। सबू वीडियोज ପାଇଁ पीडीएफ नोट्स मु पठेबी जोटा एठी ड्रॉप डाउन लिस्ट को क्लिक करी यू कैन गेट द लिंक फ्रॉम द डिस्क्रिप्शन बॉक्स। तापर मोर चैनल नेम को क्लिक कले सबू वीडियोज को मु यूनिट वाइज एच पार सिलेबस सजाई की रखिथिबी व्हिच यू कैन गेट फ्रॉम द प्लेलिस्ट एठी सर्च करि परिबो। ओके, थैंक यू। हेलो स्टूडेंट्स, आज टॉपिक रे हमें इलास्टिक एंड रिएक्शन क्रॉस सेक्शन ए विषय रे पढ़िबा। सो ऑलरेडी हमें न्यूक्लियर क्रॉस सेक्शन रो बेसिक आइडिया देखि सारछु इन द प्रीवियस लेक्चर। सो फॉर दिस पर्पस वी डील विथ टू मेथड्स, गोटे हला क्लासिकल मेकानिक्स यूज करी आ गोटे हला क्वांटम मेकानिक्स यूज करी। सो आमे एठी पार्शियल वेव एनालिसिस करिबा इन ऑर्डर टू कैलकुलेट दिस क्रॉस सेक्शन। ओके, सो फॉर दिस पर्पस आमे कंसीडर करिबा जे गोटे इंसिडेंट पार्टिकल सपोज स्मॉल x हैविंग सम लीनियर मोमेंटम स्मॉल p but zero spin, and it is striking a perfectly black target nucleus capital X at rest, as you can see in the figure. Okay, this is our target nucleus. Its relative angular momentum can be determined by the impact parameter, which is small b, and it is the perpendicular distance from the center of this target nucleus upon the asymptotic path of the incident particle, which is having linear momentum small p, right? Now in case of nuclear collision, a asymptotic path actually undeviated rahibo as long as the impact parameter b is greater than the nuclear radius capital R, and this is due to the short range characteristics of the nuclear force. Already janisha nuclear force which is very strong but short range. So we assume here the incident particle having a point mass. Okay, now the relative angular momentum of the colliding particles will be the product of linear momentum and the impact parameter. Now according to the quantum theory, this can assume a set of discrete values of h cross. Okay, multiple of h cross asibo like 0 h cross, 2 h cross, 3 h cross, etc. mone pakaw Bohr's atom model. Okay, so in general ame yaku lekhi pariba l h cross. Okay, so L value 0, 1, 2, 3 and so on. So here the impact parameter B may vary continuously, but we have to assume that in those cases in which the value of L h cross by P is less than B, which is less than L plus 1 h cross by P, the angular momentum will be L h cross, and since it must be less than L plus 1 h cross, so we can divide the whole space surrounding the target nucleus X into the cylindrical zones having axis parallel to the direction of the incident particle, and its radii will be having lambda cross, 2 lambda cross, 3 lambda cross and so on. Okay, so here lambda cross mane kono, it is h cross by p. Okay, so it is lambda hegala de Broglie wavelength. So you can see in the figure for L equal to 1 we have lambda cross, L equal to 2 by 2 lambda cross, L equal to 3 by 3 lambda cross. So the geometrical cross section suppose of the Lth zone will be determined as pi L plus 1 square minus L square h cross square by p square, which is equal to 2L plus 1 into pi lambda cross square. Now since no more particles can be taken out of the incident beam than were in it originally, so the total reaction cross section cannot exceed the above geometrical area. That means we can write the reaction cross section, that is sigma Re, to be less than equal to 2L plus 1 pi lambda cross square, and this equation does not apply to the elastic scattering cross section. Okay, ebe kebolo eta reaction cross section ame dekhuchu. Now the reaction occurs as we saw in the top when the impact parameter is less than the nuclear radius. So in this case the incident particle is totally absorbed by the target nucleus, and it can be taken to be a perfectly black one. Okay, and forms the compound nucleus. Upcoming classes रे हमें compound nucleus विषय detail पढ़ेगा. Obviously there is a maximum limit of the value of L for which this can happen. जोटा हमें calculate करी परिबा B max equal to L max H cross by P, which is equal to R. So L max रो value आसीगला R by lambda cross. Okay, ताले total absorption cross section can be written as sigma total, which is less than equal to summation L equal to 0 to L max 12 plus 1 pi lambda cross square. Okay, pi lambda cross square बाहर को पड़े आसिला. तापरे এই সমেশনটাକୁ ଆମେ লেখି परिबा এই हिसाब रे. देखो pi lambda cross square এটা आसिगला आउ r by lambda cross plus 1 रो whole square. Okay, এই থ্রু ଆମେ ଆଣୁଛୁ, right? So ଆମର final value ଟା आसिगला sigma total is less than equal to pi r plus lambda cross square. Okay, and this is true for large value of L, that is L max. Okay, that is for small lambda cross, that means lambda cross যদি small, lambda cross ର value কেতে h cross by p, so it will be having high energy. Okay, so for very low energy lambda cross is large as compared to r, so that the absorption cross section is determined by the de Broglie wavelength and can far exceed the geometrical cross section. Geometrical cross section value simply pi r square of the nucleus. So for example, in case of suppose xenon, okay, having the number 135, the thermal neutron absorption cross section is found out to be 3.4 into 10 to the power 6 barns. Okay, as we have already discussed, barns होची तमरो unit जो cross section measure करिया पाई. Okay, so it compares well with the value lambda cross square pi, where lambda cross equal to 2.85 into 10 to the power minus 11 meter for thermal neutrons having mean energy 0.026 electron volt. So it is lambda cross square pi ର value nearly ଆସୁଛି 2.56 into 10 to the power 7 barns. Okay, এটা lambda cross ହେବ ଏଠି. Okay, so on the other hand এই xenon ପାଇଁ geometrical cross section ଯଦି ଆମେ ଦେଖିବା, it is nearly equal to 1.5 barns. So it bears the statement that made above. Okay, so ଏବେ ଆମେ ଆସିବା क्वांटम मेकानिकल अप्रोच को. एबे जाय हमें क्लासिकल अप्रोच देखिला जोथरे कि केवल रिएक्शन क्रॉस सेक्शन आस्तला, देयर वाज नो इलास्टिक स्कैटरिंग क्रॉस सेक्शन. Okay, so we consider a collimated beam of mono energetic incident particles which are proceeding along the z direction, and we can represent this by a plane wave. Okay, quantum mechanics माने तमे जानि छ moving particle can be associated with a wave, that is the de Broglie wave. So it is wave particle duality asibo, so we can represent this by plane wave, which is exponential of ikz. K is the wave vector of the incident particle. Now this can be expanded in terms of spherical Bessel function GLKR as given below. Okay, या को detail expansion करिवा दरकार नहीं, केवल यार wave function टाकू देखो हमें exponential ikz, which is exponential ikr cos theta, जोड़ value हमें दे देला r cos theta, which is summation L equal to 0 to infinity. एबे हमरो Bessel function यूज करिवा 2l plus 1 I to the power L JLKR PL cos theta. Okay, এটা তুমি already mathematical physics ରୁ ବି ପଢିଛ, quantum mechanics ରେ ବି ଦେଖିଛ. Now since the observations are made as for your large distance from the nucleus, so here small r will be approaching towards infinity, so we have to use the asymptotic form of the Bessel function JLKR as given below. In the limit r tends to infinity, JLKR equal to sine kr minus l pi by 2 divided by kr. Okay, so we can get now the value of the wave function for the incident particle, it is psi incident like this. Okay, एठी देखो हमें ए हिसाब रे incident particle रो wave function बाहर कर देला. Okay, thus The incident plane wave may be regarded as made up of superposition of a set of spherical outgoing waves, that is exponential ikr divided by r, and a set of spherical ingoing waves, that is your exponential of minus ikr by r of equal amplitudes. Okay, ଏଠି PL ହେଉଛି legend or polynomial ଦେଖିବାକୁ ପାଉଛ। ଏଟା ଗୋଟେ ପାର୍ଟରେ exponential of plus ରେ ଅଛି, ଆଉ ଗୋଟେ ପାର୍ଟରେ exponential of minus ରେ ଅଛି। Okay, now in the absence of the target nucleus, the incident plane wave coming from suppose minus infinity along the z-axis will go on undeviated up to plus infinity. Okay, because किसी भी target nucleus बाटरे नहीं, so the presence of the nucleus will affect the outgoing waves only. Okay, and ingoing waves remains unaffected, they will remain unchanged. So we assume that the outgoing wave is affected both in amplitude and phase. So if the factor by which the lth partial outgoing wave is changed is denoted by suppose eta l, then we can write asymptotically the total wave function in the presence of the absorbing nucleus. Okay, in the presence of absorbing nucleus, we can write this wave function as psi r theta to be equal to 1 by 2 ikr, then the rest one एठी केवल देखो फैक्टर आसीगला eta l. ओके, कोथिरे आसीला तमरो आउटगोइंग वेव रे, आ एठी इनगोइंग वेव टा एज इट इज रहिछि, राइट। सो एठी eta l होछि इज ए कॉम्प्लेक्स नंबर, if the magnitude of eta l is equal to 1, then the outgoing wave is affected only in phase but not in amplitude. Okay, so this correspond to elastic scattering. Okay, a elastic scattering concept asila. So in general, when reaction takes place, the value of the magnitude of eta l will be less than 1, and since both amplitude and phase will be now affected, so the total wave function in the presence of the target nucleus x can also be written simply as psi equal to psi incident plus psi scattered, that is psi incident plus f theta exponential ikr by r. एटी f theta ହେଇଗଲା elastic scattering amplitude, and the scattered wave, that is psi scattered, will be equal to f theta exponential ikr by r is an outgoing spherical wave, right? अच्छा, now let us see the elastic scattering cross section, या विषय भी डिटेल हमें देखिबा। देखो, incident plane wave exponential of ikz is so normalized that there is only one particle per unit volume. So आमे जानिछु normalization process रे जो magnitude wave function रो तारो square is यार value equal to 1. So the incident flux, which is the number of particles incident per unit area, will be the product of the velocity of the incident particle with lambda incident magnitude रो square, यार value हमें 1 already पाइछु, so it is equal to v. Okay, so v, as I said, is the velocity of the incident particle. So the probability of scattering by a single target nucleus into a small solid angle, suppose d ohm, will be equal to sigma scattering theta v lambda incident magnitude square d ohm, which is equal to v sigma scattering, then we have d ohm. Okay, एठी printing mistake again अछि, छोट छोट printing mistake रहुछि, so एटा है जिवो theta not sigma, right, bracket भितर। So it is the elastic scattering cross section per unit solid angle at the angle theta. Okay, so याको हमें कोई परिबा differential scattering cross section. Okay, so you can see in this figure. Okay, देखो एठी आछी हमरो small solid angle, this is a small surface area, एठी angle create करछि theta, incident direction एठी with velocity v अछि, हमरो particle रो, this is the target nucleus is here. Okay, so it is the scattered wave function, right? Now the number of scattered particles per unit volume in the direction theta will be psi scattered mod square, which is equal to mod of f theta square by r square. Okay, so that the scattered flux will be v into magnitude of psi scattered square, which is equal to, by putting this value, v into this much. So the velocity remains unchanged in the elastic scattering. Okay, elastic scattering जो तुम जानी जो energy before and after collision समान थाए, also momentum before and after collision समान थाए, so its velocity will remain unchanged, right? So as I said in the figure, याकू यदि आमे refer करिबा, we see that the number of particles scattered into this solid angle, that is d ohm, then it passes through the elementary area, that is ds, this one as shown by the shaded region, which is equal to r square d ohm, and it is at a distance r from the target nucleus. Target nucleus will at a distance small r रे अछि, right? So the scattered flux into ds will give you the quantity finally b mod f square d ohm. Now we compare this equation with the previous one. ताले आमे एठी पाइगला differential scattering cross section, which is sigma scattered theta to be equal to mod f theta square, and f theta can be evaluated like this. देखो एठी जो wave function थिला psi scattered याको आमे निथिला f exponential ikr by r, which is equal to now total wave function psi ru आमे psi incident को फेडी दबा, right? ताले एबे आमे एथिरु f theta पाई जिबा by putting the values जोटा आमे previous equation रो आणुछु. Okay, now here I to the power l exponential of minus il pi by 2 is nothing but equal to 1. Okay, ताले f theta को आउरी आमे simplify करके लिखि पारबा. Now if we write f theta to be equal to summation of f l theta, if एठी f l theta माने कोन, it is representing the scattering amplitude for the lth partial wave. So it is given by f l theta equal to 1 by 2 ik 2l plus 1 eta l minus 1 pl cos theta. So the differential elastic scattering cross section for the lth partial wave will be equal to how much? It is equal to sigma scattered theta equal to mod f theta square. So that यार value हमें एठी put कर देला, ताले total scattering cross section for the lth partial wave will be equal to or obtained by integrating over all solid angles, so that we can write sigma scattered to be equal to integration sigma scattered theta d ohm. D ohm को हमें factorize करि परिबा as sin theta d theta d phi, ताले d phi by integration कले यार फाइनल वैल्यू आसीबो 2 pi, आ रेस्ट हमें sigma scattered theta पाई तार वैल्यू जो ऊपर पाइथिला ताकू बसई की यार यदि इंटीग्रेशन काढिबा, finally we will get the value of sigma scattered to be equal to pi by k square 2l plus 1 magnitude 1 minus eta l ro square. Okay, so एठी pi by k square को हमें लिखि परिबा pi lambda cross square. Now you know that the magnitude of eta l can be less than or equal to 1, so that एबे ए sigma scattered को हमें लिखि परिबा less than equal to pi lambda cross square 2l plus 1, right? So in the absence of reaction, since the mod of eta l is equal to 1, so we can write eta l to be equal to exponential 2i delta l. Okay, so the delta l kono eta hochi gote phase factor which is real part. Okay, so we have 1 minus eta l mod square, ebe yar value jodi put kar deba ताले 4 sin square delta l पाइगला, याको एबे हमें पुट करी की sigma scatter value पाइला when there is no reaction, remember. Okay, now एबे आसीबा reaction cross section को from the quantum mechanical point of view. Now you see the total wave function psi r is actually equal to psi r theta, right, in presence of the nucleus, and it is the sum of the spherical outgoing and the incoming waves for different values of l. So we can write psi r to be equal to summation L psi in plus summation L psi out. Okay, so psi in or psi out ro value respectively are like this. Now the radial parts of these waves yaku ame jodi lekhi pariba in terms of small g. Okay, small g in small g out is our radial part ko ame lekhi dela. Then the probability current density यार formula तमे quantum mechanics रे पढ़ी थिबो, याको denote करा जाए with the symbol J, which is equal to I h cross by 2m psi del psi star minus psi star del psi. Okay, then the incoming and outgoing current density for given value of L can be written like J in and J out like this. Okay, আচ্ছা তাহলে ডিটেল ক্যালকুলেশন যদি করিবা by using the above formula তাহলে J in ର value ଆଉ J out ର value ଆସିଯିବ like this. Okay, এটা after detail calculation. Okay, এটি direct value লিখিছি. So the net ingoing current density for a given value of L will be equal to J in minus J out. Okay, it is the ingoing. Okay, তাহলে এটি এই দুই ভ্যালুকে আমি পুট করে দেলা. সপোজ আমি কইলা ক্যাপিটাল N to be the flux of the incident particles. Okay, number जोटा अछि. Then the reaction cross section for the Lth partial wave will be how much? Sigma Re, which is equal to Nre by N or Na by N. Okay, এটি Nre by Na actually it stands for the total number of particles, A for absorbed or Re for reaction, okay, which are going through a spherical surface of radius small r. তাহলে এটি Na ର value ଆମେ ଲେଖି ପାରିବା to be equal to minus double integration J r square d ohm PL cos theta ର whole square. ଏଠି minus symbol ଗୋଟେ ଲାଗିଛି because in order to make the net number of absorbed particles positive, right? তাহলে we have Na equal to now this much. এটি JL ର value ଆମେ ଏବେ put କରିଦେଲା ପରେ याको पुणी यदि solve करूछु we will get a simplified quantity like this. So the incident flux will be how much? Capital N, which is equal to the product of the velocity and the magnitude square of psi incident, which is nothing but V or P by M or H cross K by M, right? তাহলে sigma Re, which is equal to Na by N, তাহলে यार value ଆମେ put କରିଦେଲା. Okay, N ର value ଆଉ Na ର value याको ଏବେ ଯଦି simplify କରୁଛୁ we are getting the value of sigma Re like this. ताहले हमें elastic our reaction cross section रो final value पाइगला. So that the total cross section and its limiting values को ଏବେ देखिबा. Total cross section कोन होबो दुईटा जाकर समष्टि याको हमें पुट कर देला final value एतिकी आसिला 2 pi lambda cross square 12 plus 1 1 minus real part of eta L. Okay, so equations जो ऊपर हमें दुईटा देखिथिला 11.315 11.329 they give us the possible values of the two cross section which are shown graphically as a plot of sigma scattered against sigma reaction both in the units of pi lambda cross square 2l plus 1. As you can see reaction को हमें x axis रे नीचू scattering को y axis रे नीचू ताले देखो scattering रो maximum value एठी आउची 4 with eta l equal to -1 तापरे ई शेप रे आउची. ओके, एठी eta l equal to 0 with 1 then eta l equal to +1 रे एठी reaction रो एठी value टा 0 ही जाउची, right? अच्छा, so we can see here जेमती हमें फिगर रे देखिला possible value टा एई range रे आसुची, right? ताले it can be seen for eta l equal to -1 sigma scatter equal to 4 pi lambda cross square 2l plus 1 attains the maximum value while sigma Re attains the value equal to 0. Eta l यदि equal to 1 नौज ताले both will be equal to 0. Okay, for eta l equal to 1 देखो এই পয়েন্টে রହୁଛି দুইটা যাକ 0 ହେଇ ଯାଉଛି and for eta l equal to 0 এটি দুইটা যাକର ভ্যালু pi lambda cross square 2l plus 1 রହୁଛି ओके सेम ভ্যালু রହୁଛି এই জায়গায় right so we see that there can be elastic scattering without any reaction because highest point at eta l equal to -1 এটি আমি দেখিলা যে ইলাস্টিক স্ক্যাটরিং রହୁଛି যদিও রিঅ্যাকশন ପାଇଁ 0 রହୁଛି so there cannot be any reaction without scattering vice versa কিন্তু ହେବ ନାହିଁ okay so the possible values of sigma scattered sigma reaction lie within the curve as shown in the above figure right তাহলে ଏବେ जो ଆମେ इक्वेशन देखला इक्वेशन नंबर 11.330 ସେଥିରୁ ଆମେ total cross section for all values of L ପାଇପାରିବା sigma t equal to the summation over L which is equal to summation of the scattered and the reaction cross section so यार value एतिकी पाइला हमें now we also have from equation 11.313 for theta equal to 0 f0 which is equal to this much याको एबे जदि सॉल्व करिबा यार इमेजिनरी पार्ट बाहर करिबा we will finally came to the famous theorem which is the optical theorem okay sigma t will be equal to 4 pi by k imaginary part of f0 okay this relationship is known as the optical theorem and it give you the relationship between the total cross section and the imaginary part of the forward scattering amplitude and this is a general consequence of the wave theory এটা তুমি quantum mechanics রে পড়িଥିବ okay so it is due to the destructive interference between the incident and the scattered waves okay तापरे ଆଉ ଗୋଟେ ଜିନିଷ ବି ଏଠି ଜାଣି ରଖ what is shadow scattering देखो for a completely absorbing nucleus having eta l equal to 0 there is still elastic scattering cross section of up to pi lambda cross square 2l plus 1 which is equal to sigma re in this case now for the total cross section which is actually twice of the geometrical cross section then if we consider the case of such a black nucleus having some radius r which is much larger than lambda cross then we have the total elastic scattering cross section and the total reaction cross section values as sigma scattered equal to pi r square which is also equal to sigma re and the total cross section will be the sum of these two তাহলে আসিগলা 2 pi r square so the region for occurrence of elastic scattering even when there is complete absorption lies in the so called shadow scattering so for this purpose যদি ଆମେ suppose n number of neutrons consider kariba which are incident per unit area per second on the nucleus and they represent an area suppose pi r square to the incident collimated beam then the number of neutrons absorbed by it will be n pi r square okay তাহলে further analysis যদি করিব তাহলে তুমি দেখিବାକୁ পাইব যে as the shadow will be produced behind the nucleus okay shadow जोटा nucleus रो shadow गोटे produce हबो behind it and this shadow will not be sharp because of the diffraction phenomenon diffraction जानिछो it is the bending of light around the corners of an obstacle so यार edges गुडा sharp हबो नहीं okay completely blurred ହେଇକି ରହିବ at some distance capital L behind the nucleus where L is the quantity having order of r square by lambda cross or larger okay and this is very large for most black objects okay तापरे एठी यदि न्यूट्रॉन्स तमे नउचो around 14 MeV energy then lambda cross equal 1.25 into 10 to the power minus 15 meter so even for fairly having nuclei of radius r is only a few times of lambda cross and this implies that the trajectory of the incident neutrons are bent at the nuclear surface due to the diffraction through scattering angle that is lambda cross by r. So the number of scattered in this way has been calculated theoretically and turns out to be just n pi r square, giving rise to cross section pi r square. So total ହେଇଗଲା 2 pi r square. So याको हमें फिगर रे भी देखि परिबा. देखो, these are the incident particles as represented by the arrow mark. एठी हमरो target nucleus अछि and this is the shadow, right? Okay, so याको experimentally भी देखा जाइथिला. The experiment of Amaldi and his co-workers on the angular distribution of elastic scattering of 14 MeV neutrons by lead are in good agreement with the theoretical data. So in addition to the general shape of the scattered neutron distribution, they have observed the subsidiary maxima at the approximately expected angles. So this is all about the elastic and the reaction cross section. Okay, now I have taken the same topic, that is the elastic and reaction cross section, from another book, as you can see. So you can read from this book also. ଏଠି भी सेम जिनसକୁ बुझेइछि. ओके, नोटेशन किछटा अलगा थाई पारे, केतेटा जिनसरे तमे कॉन्सेप्ट भी या भितरु एक्स्ट्रा पाई पारो. ओके, so you can read from this book also and make your note accordingly. Okay,
Thank you.